to have a general understanding of Arduino. The second objective is to understand the hardware and the software aspects of Arduino. And the third objective is to understand Proteus. And also, we will do a simple project that will help us consolidate everything that we're going to learn today. So, let us begin. And the beginning, I would start with why the idea, why Arduino. So let us start with the idea behind Arduino. And for a start, okay, most of you have been around urban areas or even around here, that is around school, because majority of you come from KU. And we normally see the street lights that are normally on during the night and off during the day. No one controls them. They just basically do it on their own. So for this, normally these street lights, they always have sensors embedded in it. Those are the photoresistive sensors. And also they have the light, the LEDs that are used for lighting now. And the incorporation of these street lights on how they work, that is done basically. This involves controls in electronics, and what is used basically is a microcontroller unit. So what is Arduino? Arduino is one of the company that produces microcontroller boards. So Arduino is not a microcontroller on its own. It's just one of the company that produces microcontroller boards. Definitely we have other companies that deals with producing microcontrollers all over the world. Arduino is what happens that you're going to deal with and handle for this skills webinar. And Arduino boards are of different types, but majorly we have three known and commonly used boards. And the first one is an Arduino Nano. The next one is the Arduino Uno, and the other one is the Arduino Mega. So when you talk about a Nano is a smaller version of it. That is the hardware component we're talking about here. And Arduino Uno is slightly a larger one, a larger component, hardware component, in comparison to a Nano, but it is also smaller in comparison to a Mega. Arduino Mega is now the larger one, the largest among. So from my photo, we have on the left side is the Arduino Uno, and on the right side we have the Arduino Mega. And from the Arduino Uno, what you can notably see is that it has 14 digital pins and 6 analog pins, meaning the total number of pins are 20. When you look at the Mega, Arduino Mega, we have 54 digital pins and 16 analog pins. So the total number of pins that it can handle are 70 pins. What is the significance for us to consider the number of pins? When it comes to prototyping, it depends with what you have. A smaller prototype would just require a smaller board since it has smaller number of pins. But when you encounter a situation where you have a larger prototype, you will be forced to use a board that has more pins. And when we talk about pins are ports where we will place our inputs and outputs. When you go back to our first case example scenario, when we were talking about the idea behind Arduino, we had a sensor, that is a photoresistive sensor, and we had the LED. And in between, you can have a bigger project that would require a lot of pins. So I picked one of the board to explain the components in it, and the board I picked was Arduino Uno. So from the picture on your screens, you can see the board clearly, and we would start with the first component. The first component is the USB port. What is the function? The USB port provides connection to your computer. This is the point where you would connect a cable to the computer, and this is the point where the code is uploaded to the board. Also, normally USBs also can support the board by powering it. It can support the powering option for the board. Either way, if you don't want to power your board using the USB port, there's a power jack as it has been indicated. And what you have to know about this Arduino Uno, it uses lower voltages. So a voltage of about 5 volts is always sufficient for it. And something above that or above around 9 will entirely damage it. So you have to consider anymore. You just have to reset it. And that is the function of the pin. And also from the board, you can see the position of the digital pins. They range from 0 to 13. And after the pin number 13, you can see the GND, that is the ground pin. Also, you can look here below. We have the analog pins, and our analog pins are from A0 to A5. Those are the analog pins. And also to the right side, we have the power. To the left side, I mean, we have the power pins. And the power pins, we have, okay, if you look closely, we have the 5 volts pin, and we have the 3.3 volts pin. And also we have 2 ground pins. Those are the most important power pins that you're going to use from this board. So next is, we've been talking about pins from our Arduino board. So what you're going to handle next is what is the difference between analog pins and digital pins in an Arduino hardware component. So the difference between the two, let us start with the analog pins. Analog pins handle analog signals. And analog signals, from the right side, you can see an analog signal. Analog signals have range of states. With the amplitude, noted the difference between the digital signal and an analog signal. A digital signal would only have 2 states. And with the Arduino concept in mind, we'll name those states as an on or off states. Normally, an on state would have maybe, for example, a 1, and an off state would have a 0 in it. So basically, that is a digital signal. And one of the example of a digital input can be a push button. That is, it is either connected or disconnected. And those are connected to the digital pin section. So for further understanding of these digital pins and analog pins, we can look at a case example. And I would use a case example of controlling a fan. Remember, you can have a fan and you want to automate this fan by using an Arduino. So one of the options is to control it using the digital pins. And when you control it with digital pins, you will have 2 states. That is an on or off state. You will either turn it on or turn it off. I hope that is clearer. And another option of controlling a fan using Arduino, you can control a fan using analog pins. And this would mean that you will have a range of states. And since Arduino uses Atmega 3, what we talk about when we say digital pin and an analog pin, and how to use them respectively. Okay, from there, I think the general understanding of the general concept of Arduino has been handled. And before we go to the software aspect of Arduino, I would do an introduction to Proteus. Proteus is another software. It's completely different from Arduino. And Proteus is a design suite developed by Lab Center Electronics. And it is normally used for circuit design and simulation. We have PCB. PCB is printed circuit board in full. So we have the PCB design, and also recently it is being used for IoT building. But for our webinars, we are going to majorly deal on circuit design, that is development of a circuit diagram, and how to simulate it. So that is the first application only. But out of interest, that is generally what Proteus is used for. So by default, we have .idx extension. So these files are going to be copied and you just paste them in the Proteus software library folder. It is an easy step and it is so much straightforward, but you can demonstrate one. Before that, I would like us to the project. Our project is a basic traffic light control project, and we're going to have components, that is LEDs as our outputs. We're going to write code from the Arduino Ide to control the LEDs, and you're going to link the two. So connection and the connection of components, since you're doing a skills webinar, it can't be physically, definitely. So that is where Proteus comes in. You're going to develop a circuit diagram for that on Proteus, and that is what I want us to do right now. So our general development diagram looks like that. I hope you can see it from the screen. We have many components. We have basically 4 components, 3 LEDs, and they are colored. We have a red LED, a yellow LED, and a green one. And when you want to do that, the first step is to access the schematic capture. Click at that point, and you will have this workspace given to you. That is on the right side. And on the left panel, we have devices with P and L. The right side is your workspace. This is where you're going to place your components. And on the left side, that is the left panel. That is where you're going to pick your components. And before we do that, one of the most important things to do with this software is save your work just before you start. So to save, you're going to use the file option, and you will save your project. Save as, for example, do it at any place, and we can name it traffic controller. That is already saved, and I think it is wise to do that, since you can develop something and after some time it vanishes and you're not going to retrieve it. So save it first, and saving is as simple as that. So how to access the component libraries? You're going to select it from your left panel, that is the P, and when you do that, is a window pop up, and we have this interface. We have Q, and to access that, you can type it Arduino Uno. Yeah, basically you only have 2 Arduino Unos. You have an Arduino Uno and a Genuino Uno. Basically, this is the same thing, but manufactured by different companies, Arduino and Genuino. So let us pick Arduino. To pick it, you double click on the component, just as I have done. And on the left panel, you can see on the background, the component is listed. So the next thing we want to use is LED. I hope you can see, you can type LED, and now these components, you just type LED, and there's so many. The library is so huge, you can filter them, but I think you can get what you want. I'm going to pick LED which are colored, the LEDs which are colored. So I would need a green one. So double click on the green, as I have done. I'll need a red one. Double click on it, and I will need a yellow one. Double click on it. Red, yellow, green. Those are normally the traffic lights colors we see. So that is why I've chosen them and component for it and place it multiple times the way you want it to appear on your development diagram. So let us start by placing components on the workspace. And how to do that, you're going to click, that is left click on the component and go to the workspace where you want to place it, and also left click. When you left click, it doesn't place the component on the workspace. What it shows you, it highlights. So with that, also with that feature, you can just position it to a place you really want it to be with you seeing the component itself. So I can place our Arduino at that spot, and you can see our Arduino. We have the analog pins. Let me zoom in. You can see we have our analog pins, we have our digital pins, we have our, okay, we don't have our power pins because this Arduino is automatically programmed to power using 5 volt software. Okay, I said this Arduino Uno, this is the real one, but on the, I would only want us to connect only 2 LEDs. The rest you've seen it from the diagram. So this is the component you want to place, and if you don't want to place the component in that orientation, there are so many features on how to reconfigure your orientation. You can rotate you can rotate your component, and also, yeah, it is the rotation, a very important aspect with placing components. So I would want us to place our component in that order. So I would start with the red one. And maybe I'll connect also a green one. I still hope we are on the same page and you're seeing what I'm seeing over here. So after you've placed your components, you can connect them, and connecting them is very simple. Once you have your components placed, you can move this pencil from the screen. Hope you can see it. Let me zoom in. Once you're at the tip, and they are connected in parallel, meaning only one pin can do the job of lighting these 2 LEDs. So from there, when you are connecting LEDs, the negative terminal has to be grounded. So how to ground, or where to access ground from this Proteus software? You have on your left side, from the left panel, but on the left side, you have a number of icons. You have a component mode icon. This lists the components that we have. We have what we need now. We have a terminals mode. When you click on the terminals mode, I hope you can see, you have default, you have input, outputs, power, ground, dynamic, bus, and from here we can have our ground. This is our ground. You just left click on it and place anywhere you want on the software. Also, we have other icons and other components that you can use, but for this development diagram, we don't need a lot of things. You only need the ground. But for demonstration purposes, we can have, for example, the generator mode. That is where you have the DC generators, the AC generators, pulse generator, audio generator. You have clock generators, and also you can have our from a non-circuit, which you've just researched from online. You can just redo it, connect, do the connection. It is pretty simple and pretty straightforward. So up to that point, I think we've covered Proteus and Arduino hardware and an introduction to it, and developed a diagram using Proteus. This is only an ice tip. There are a lot of things to do with this. but due to time, I'm going to stop there and welcome my colleague. I hope, Anthony, can you get me?
Yes, yes. Thank you.
Yeah. So, Anthony, welcome.
Thank you. So, good morning, everyone. Yeah, this is interesting that you're here, and I hope you're enjoying. Yeah, so we shall get into what I want to show you right now is the code in the
Okay,
IDE. Hello, you can hear me?
Anthony, there's a lot of background noise.
Oh, okay. Sorry. I hope now it's over. Yeah. Okay.
Not exactly.
Not exactly. Oh, give me
Yeah,
this.
you need to look into it.
Talk about the Arduino Ide. We shall talk about the libraries. We shall talk about the code, and basically we shall just now understand the how it how you actually put instructions on the hardware that Tony has explained. So allow me to share with you this. This is how the Arduino software looks like. Can you see my screen? You can see my screen.
Yes.
Okay. Okay. This is generally the IDE. I have opened the program that we shall be seeing as our project, which is the traffic light challenge. I want to walk you through this IDE in a 3 seconds or in a very short time. Basically, you can see where my cursor is. You can see there's a file, a tab, which is file, the edit, sketch, tools, and help. You can see a tick, an arrow pointing to right. Then you can see a save icon, a new icon. That's an icon to, if you click this, it will open a new sketch. This is how a blank sketch looks like. And on a blank sketch, you can see on this tab file, you can see the various options that are there. One of the, okay, these are very common in preference one. The preference, you can see there's a very unique command, and I just want to show you one that is important for this webinar. You can see where my cursor is, I guess. There's a command called show verbose output during output during compilation and upload. This is important for this webinar, especially because it stopped. Okay, it's clicked right in. Now I've unclicked. Once we want to link our Arduino to Proteus, we will have to use a hex file. I will show you in a second. That hex file will be visible if only we have selected these options to yes, like we have clicked them, right? Like show verbose output. Yeah, so you might want to remember that. The other options, they're a bit complex for now. I'm assuming that most of us are new to Arduino, so I don't want to put so many information, so very many new. Just want to stick to the most basic. So that's important. There's the edit tab, which has pretty much very common here. And you want to copy, paste, you select, you go to a line, you comment, ident. Ident is to like put the code on a sketch. Sketch is important because Sketch has one of the things that I will talk to you now about, and that's the libraries. Libraries, I would say, they are it's a compiled code that they abstract you from. You don't really know what happens inside there. You don't want to know right now, not unless you want to create your own library, which is possible. But a library will help you. Will help. Like we have, for example, let me just show you a library, like the Ethernet one. If you have a project that you want to connect to Wi-Fi, you will have to make use of a library, Ethernet, or you can use a GSM GSM is when you want to connect, you make your project to use a SIM card, the SIM card that we use on phones. Yeah, so libraries will be necessary when you're dealing with a certain, it's like it gives you very many commands at the same time, so you just need to use the module to do what you want to do. It's pretty abstract right now, but it will be very clear in a short while. Yeah, and I'll show you how to add a library. These are the list of those libraries I was explaining to you. This is where you'll find them. And if you want to add a library, you download a library from the internet. Mostly GitHub, you'll always find library you want. So you can very easily find the library you want. And then you can paste it here. Once you download it on this folder, you find the folder Arduino and then find the libraries, you add it. And then if you have already opened your Arduino, you have to close it, and then you close this star one, of course, and then you reopen it so that the library can get integrated in the IDE. That's important. That's on the sketch. That's important. The upload, as you can see, the verify and compile, the upload, these are their shortcuts. You can see once I hover my mouse on top of this right, it's like a right symbol. You can see verify. Let me just show you right now. If I want to verify this code that I'll be explaining in a minute, you'll have to click here. Then you can see the compilation sketch below. Then you can see that green bar which shows how it's compiling, and then compiling the sketch tools tab, and then make sure that the board you're using is selected. As Tony has just said, there are very many Arduino boards and very many other microcontroller boards. Like you can see there's Arduino Uno, what? I can't even read that name right now. Nano, Mega Ide, all this. Just make sure you have selected the right board. And then make sure you have selected the right port. Like you can see the port right now, it's COM3. If you connect physically your hardware, if I can do this in a second, I connect my Arduino. I have an Arduino, so you can buy an Arduino if you like. It's 1,000 shilling or less. Okay, let's see whether it reflects. We can actually upload. It's possible to upload because I have connected my Arduino, my personal Arduino. Yeah, so I wanted to show you how the COM. You see, there's the COM5 which is connected to Arduino. Make sure it's connected to Arduino. Yeah, if it's COM3, for example, your code will give you some problems. You want to make sure that you're using the right board and you're using the right port. Yeah, on a more complex, to create that, remember I told you here on the preferences that you needed to place compilation and upload as ticked here. Now, as you can see, we already project, and once you see this output, there are very many and it's complex. You may fear, but don't fear. Once you verify your program, the code, yeah, it will give you these lines of outputs which are telling you things are pretty awesome, because you can see it has completed uploading. Oh wait, let me remove this semicolon and you see what happens when there's an error. Run. It's compiling. Boom, we have a problem. It expected a semicolon before the. If you're pretty familiar with programming, you know errors such as semicolon are very, pain in the ass. But boom, you need to the this will give you error where they are, so it's possible, and it will easily tell you there you needed a semicolon, and then you verify again. You can see things okay, we have explained the IDE, the libraries, the code, and now what we want to do, we want to see how Proteus and Arduino collaborate. As Tony has explained what Proteus is on a nutshell, we shall not get back to that. We want to apply our code to this project, the project that Tony just introduced us to. Okay, now what I'll do, I will come to, okay, and I'll make turn also traffic. So you can see my code, and you can see my code, and you can see my project. Yeah, the project Proteus. Okay, this is a traffic lights project. I won't talk to you about how traffic lights work. I won't get you back to class 4. But what I'll do, I'll show you the logic of the code. The logic of the code is you create variables. The variables are the pins that Tony just explained to us. He talked about Arduino having 13 pins, input out digital pins, talked about 6 out analog pins. These are the pins that on the highlighted area, you can see my red LED, I've connected it.
Delay, but that is basically how to run a simulation. From here on now, what are the advantages of this Proteus? From here, you can now fully understand how your circuit works, be confident that your circuit works in the first place. Also, from here, you can now know the exact components you need to develop something, a project. Remember, when you want to work on a project, there's some cost to incur when buying electronic components, which are quite expensive. So from this software, you can be sure on what you are doing, and also cut costs by buying the equipment you only need. No need for more equipment. So I think that simulation is okay and done. And since it's 12:05 past our time, I would like to welcome other question sessions.
So hello Tony. Can you hear me?
Yes, Ronnie, I can hear you.
Okay, so as Anthony was presenting on the on the part where it was compiling, he kind of he had copied some hex or something. So is that the hex thing that Anthony copied?
Be empty. There would be no program running your Arduino. So to have one, you have to upload it, and to upload it to a virtual Arduino on the Proteus software, you have to use the hex file that was shown on how to extract from the IDE by Anthony. Are you okay with that?
Yeah. Thank you for clarifying.
Okay. Another question which I didn't answer is from Mike Mudomi. What are the safe sites for downloading Arduino extensions? So clearly, I didn't understand what you mean by Arduino extensions, Mike. But if it is sites for downloading Arduino libraries, briefly I can show you how to do that. Okay, you can just go to any site online using your browser Chrome and download anything. But there's a simple way on how to do that. And how to do that, you just have to access manage libraries from the tools options from up there. Hope you can see it, and click on manage libraries.